Alright, this is the reassessment video for forces in circular motion. I'm going to redo the same problem we did in class with a ball hanging from a string at a 25-degree angle and with a 0.8 meter length string. You asked to find the tension of the string and the linear velocity of the ball. What the linear velocity of the ball would have to be. So to find the tension of the string, we know we'll use the y component. We know the forces in the y direction are equal to 0 because it's not accelerating. And then the forces are the tension times sine of theta we get from the angle minus the force of gravity, which equals 0. So we solve for the t, we get the force of gravity over sine of theta, and we plug in all the numbers, we get 0.05 kilograms times 9.8 newton kilograms over sine of 25 equals 1.16 newtons. Now to find the linear velocity of the ball, well, we know that the sum of forces equals the mass times acceleration in the x direction, and the acceleration in the x direction is equal to negative velocity squared over the radius, and it's negative because it's in the negative direction compared to the origin. And so the sum of forces is equal to negative tension times cosine theta, same thing as earlier, and that is equal to max, which is mv squared over length times cosine theta. We get the length by drawing a triangle. We know that r is equal to the length times cosine theta because it's adjacent over hypotenuse. So the length times cosine theta equals r. We can plug in, we can put all that together, solve for v squared, or we can solve for v, take the square root of everything, and plug in all the numbers, plug in the tension that we got over here, the length that we got over there, cosine of the angle, cosine squared of the angle, and then the mass equals 3.9 meters per second.